Hey geometry team, and welcome to Unit 6, Day 4. This is going to be our last new segment, our last new day on our unit of congruent triangles and their proofs. And so today we are focusing on a lovely little acronym called CPCTC. This means that corresponding parts of congruent triangles are congruent. What that tells us is that if you got two triangles that are congruent, all their parts, when you line them up, must also be congruent. And I sure hope you're thinking that, wow, that's obvious, Mrs. Cerna. But if it's not obvious, let's chat about it for a minute. If you prove both triangles congruent, you can use that to then say any parts you weren't sure about matching up now do indeed have to match up. And so then you can say that corresponding parts of congruent triangles are congruent. CPCTC. See if you can say that 5 times fast. Okay? And so you can use this as a reason to say two parts of triangles are congruent that you didn't know ahead of time. We discussed this a little bit back on day 2. We hit on it just a bit. We're hitting it harder here where we've got our overlapping and mixed up triangles here. So here's an example. First proof. I am given that AB is congruent to DE. So I'm going to go ahead and grab my given and put it here. Then I have another given, which is this angle A is congruent to angle D. I'm going to go ahead and throw both those in there because we like our givens. Now, my recommendation is that you always mark your pictures and even draw them on your own paper if you have them online. So I'm going to go ahead and mark. I've got AB is congruent to DE. So that's this guy is congruent to this guy. And then I've got that angle A is congruent to angle D. Now, they want me to prove that angle B is congruent to angle E, and I've got nothing. There's no parallel lines here that I can use. They're not vertical from each other. There's nothing. And so this is where you start to panic and go, I can't prove it, until you remember, these are parts of triangles. If I can prove the whole triangle is congruent, I can go back and then say that my parts have to be congruent. So I'm going to go with, all right, let's see what else I can find in here. Well, I know that this angle in the middle, angle BCA, is a vertical angle to this guy over here. These guys right here, they're directly across from each other. They're vertical angles. So I can say that they're congruent. So angle ACB and angle DCE have to be congruent because they're vertical angles. Well, now that they're vertical angles, I have two sets of angles being congruent. So I have an angle and an angle. And then I have a side that are congruent. I have 3 pieces of triangles being congruent. Let's see. So I can probably say the triangles are congruent if I have one of my acceptable congruency setups. So you go, okay, well, let's see. I've got an angle and an angle, but then I have a side sticking off the end. So instead of being angle side angle, this is going to be angle angle with the side off the end. So I can come over here and grab angle, angle, side and say that that makes triangle ABC. So ABC congruent to DEC. And notice that that order is very important because we're saying that the red one is congruent to the red one and that B is congruent to E and that the two angles at C are congruent. So it's very important that you have it in this order, ABC and DEC. Well, now that the triangles are congruent, now I can go back and say, well, wait a minute. The B and the E are corresponding parts. Angle B and angle E are corresponding. So I can use CPCTC to say that they must be congruent because they are this missing angle out of each one of my triangles. That's all CPCTC is going to be for you, is just an opportunity to find something else. And so let's try another one and see if you can spot what's happening here. So on this triangle, I am given that AB is congruent to CD. I've already filled it in my proof, and I'm just going to say that AB is congruent to CD. And I have marked it. And then I'm also told that BC is congruent to AD. So BC is congruent to AD, and now I have marked that. And I want to prove angle BCA, that's this little guy down here, is congruent to this little guy up here. That would be easy if I had parallels, but I don't have any parallels. So instead, what I'm going to think about is, well, maybe I can prove the triangle's congruent and then figure out that the parts are. Well, I already have two sets of sides congruent here in my triangles. And since the triangles are smushed together, I could go with this third side being congruent to itself. And so I'm going to say, all right, I can do that. Where's my mouse? Come here, mouse. There you are. I'm going to say that AC is congruent to itself. And I can say that because the reflexive property tells me that I'm always congruent to myself. And so that third side of this triangle is the third side of this triangle. Now looking, I have sides, sides, and sides congruent. And so I can say that these two triangles are congruent using my side, side, side congruency. Now that I have those set up, now I can go in and, BCA, angle BCA right here, is going to be the corresponding part to DAC there, because this one is in between the red and the green marks, and this angle here is between the red and the green marks. So they're corresponding parts. Since they are corresponding parts, I can say that they are congruent according to CPCTC. Corresponding parts are congruent in congruent triangles. Our last one now. I dare you to pause this and see if you can do it on your own before I fill it in. So here's your chance to pause. And then if you didn't take that chance, let's go through it together. Okay? So I have AD is congruent to CD. So AD is congruent to CD on these triangles right here. And then I'm told that BD is perpendicular to AC. Okay, so AC and that one's perpendicular, so okay, keep that in mind. And I'm going to be looking to prove ABD, that's this guy, is congruent to this guy. So I'm looking for these two angles here. Well, those are both the top pointy angles on two triangles that are next to each other. So I'm going to suspect that there's probably congruent triangles that need to be happening here. So knowing that, I'm going to see if I can prove that by proving the whole triangle congruent and then going for those parts. So I'm going to say, all right, well, I've used that these two segments are congruent, but I haven't used perpendicular yet. So I'm going to shoot to use that one first. Perpendicular lines make right angles. And so I'm going to go ahead and say that, all right, these two angles are right angles. So I'm going to say that this guy, come here, buddy. There you go. And this guy are right angles because BD is perpendicular to AC. And that's my definition of perpendicular lines. Perpendicular lines make right angles. Now that I have right angles, you can't prove triangles congruent unless you say congruent. Just like booping the snoot is not a boop unless you say boop. Unless you say congruent, you ain't congruent. So we need to say now that these two right angles are congruent to each other. So angle ABD is going to be congruent to CBD because all right angles are congruent to each other. That's my right angle congruence theorem. Once you have that now, and you go, okay, now I've got angles congruent and sides congruent. I just need one more thing. And we're being saved again by the fact that these two triangles are connected. They share a side. And so that side is going to be congruent to itself. So I will take that segment BD is congruent to segment BD by the reflexive property. Now I have a side and a side are congruent, and then this right angle in between them is also congruent on these two triangles. So that's telling me that I have side, angle, side congruency here. So side angle, side congruence is telling me that my two triangles, and notice I've had to pick the one that has the triangle symbols. They're kind of small, but that says triangle ABD is congruent to triangle CDB. And again, order matters. I had to say that A came first, so C came first. Then I had D, and then I had B, so that my corresponding parts are named in the proof. Then, since they're corresponding, now I can say that those two angles that I was attacking are going to be congruent according to CPCTC. All right, that's all there is for CPCTC, folks. You prove the whole triangle congruent, and then you can say all the individual parts are congruent. Good luck and have a great week.